This is the problem that we're doing today. We're basically given a H view, and then we're trying to find what the value of the E view is using the curl, basically. So the first one we should pay attention to is that the problem says it's a current-free magnetic medium. And we're also looking for a relationship between E and H view, so we should be thinking of this source-free Maxwell equations right here. It's equation 6.1 in the book. And the second thing we should notice is that the problem asks to use the Phasor equation to solve the problem. So the Phasor equation is basically representation of Maxwell equation by using these spatial vectors. This part right here is what the Phasor equations are. The reason to use the Phasor equation instead of the Maxwell equation is that it just makes it to be easier for algebraic manipulations, because we get rid of like the derivative term right here. So since this problem is we already have the value of H view, and then we're trying to find what the E view is. So we should use this equations right here. And also remember that the problem says is a current-free medium. So JF in here should be equal to 0. So the equation becomes this. So now we can start calculating the curl of H. And what I would like to do is break this H field down into the C and X components. We can start with the X term right here. And it would just be the derivative of Y on this term. And the derivative of Z on this term, which is 0. So this gives us this term right here. And we can move on to the Y components. It would just be the derivative of X on this term, and then minus the derivative of Z on this term, which gives us this right here. And the last one we're gonna do is the Z components. So this would be the derivative of X minus the derivative of Y on this term. And this would give us this component. And after simplifying it a little bit, we can find out that this goes to 0. And this term doesn't even have an X in it, so we can just ignore it. And this term doesn't have a Z in it, so we can also ignore it. The derivative comes out to be 0. So after simplifying it, and this would be the two terms that we have left, and we can do derivative with respect to Y on both terms, and this is what we get. And we can calculate E by just shifting things around a little bit to move this around here. And by doing this, this will introduce a 1 over j term right here. And we can convert this 1 over j into negative j by using this process here. Because the problem says that the field has to be a real quantity. So this negative j is basically a negative 90-degree phase shift. And if we do negative 90-degree phase shift on the cosine term, it will turn into a sine term, and we can get rid of the j component. And after this, we need to find out the value of epsilon. And we can do it by using this equation right here. Plug in all the value that's from the provided H field. Omega is 10 to the 8th, and K is 5, as we can see here. And we solve epsilon, which is equal to 225. And at the end, we can just plug everything back into this equation. And here's would be the answer. Thank you for watching.